Okay, so I have uploaded recorded videos. Are you able to see those videos? Have you checked it? Okay, so what we were talking about last time? Limit of a function, right? And what we wanted to prove, limit x tends to 2, f of x is equal to 4. That was our claim. Limit x tends to 2, fx is equal to 4 means given any epsilon, we can produce delta such that whenever distance of x from 2 is less than delta, then fx minus 4 is less than epsilon. So we wanted to make fx minus 4 less than epsilon, that means x square minus 4 less than epsilon, but we can simplify so that we can guess what will be the possible delta. So x square minus 4 is x minus 2, x plus 2, so it is same as absolute value of x minus 2, x plus 2. Fine. So now, what was our idea? Can you control the term x plus 2, right? We wanted to control this term x plus 2. And if somehow we are able to control the term x plus 2, then it will be easy to guess the possible value of delta, right? So, so how to control x plus 2, how to get some number which is bigger than x plus 2, right? And to control x plus 2, what should be controlled? Do you understand what we discussed last time? You understood or not understood?
Yes, sir, understood.
Right. So basically our aim was to control x plus 2 so that we could have fx plus minus 4 less than this quantity. And then if you want to make this quantity less than epsilon, that means x minus 2 must be less than epsilon by m. What is m? M is the number which control x plus 2. Right. So x plus 2 less than epsilon by m. From that we can guess our delta could be epsilon by m. That was my idea, or that was our thought process. But here control x plus 2, but that means what is a number which is greater than x plus 2, that is not certain, right? Right now I don't know where is x, and if I say m is 100, then I can say my x is 101. So how it is less than? So in general we cannot control x plus 2, but if you put control on x, then certainly we can control x minus 2. So what is a control on x? Ki x minus 2 less than 1. That means I am assuming that I am putting some condition or control on x, that the distance of x from 2 is less than 1. Right, that means x lies in between what? 1. So x lies in between 1 and 3. So that is what I wanted to control. So suppose I put control on x, means x lies in between 1 and 3. Then ultimately x plus 2 is, absolute value of x plus 2 is less than 5. That was my controlling number m. Right. Therefore, if distance of x from 2 is less than 1, then what is f of x minus 4? Is x, absolute value of x minus 2 into x plus 2. But under this condition, x minus 2 is less than 1, what I can say here, fx minus 4 is less than what? Yes.
Less than mod of x minus 2 into 5.
Right, because if I control x, ultimately x plus 2 get controlled and it is less than 5. So therefore, fx minus 4, because our ultimate aim is to make this quantity less than epsilon, right? So note that fx minus 4 is less than epsilon if, right, because our aim is to make this less than epsilon if, right, if x minus 2 into 5 is less than epsilon. So to make this less than, it is sufficient, that is if x minus 2 is less than epsilon by 5. So to make fx minus 4 less than epsilon, it is sufficient to make x minus 2 less than epsilon by 5. That is what I understood from this, right? Is it clear?
Yes, sir.
And now what should be delta? So that we choose delta is equal to, what delta I should select?
Epsilon by 5.
Epsilon by 5 is fine, but this is with respect to some more additional condition. Ki I have restriction on x, ki distance of x from 2 is less than 1. That condition is there, so I should include that also,
So
right?
infimum of 1 and epsilon by 5.
Right, very good. Because with respect to that condition, I got this epsilon by 5, so I should have minimum. And once I choose minimum of these two, certainly this delta works, right? So next, to verify that this is the required delta. Right now we want to check that this is the required delta which we wanted to investigate. How to check? So for if distance of x from 2 is less than delta, suppose distance of x from 2 is less than delta, what we expect when we believe that this is a required delta? When we believe that this is a required delta? Yes.
If fx minus 4 is less than epsilon.
Right. So when we believe that this is a required delta means if x distance of x from 2 is less than delta, that means x is lies in between 2 minus delta to 2 plus delta, and x is not equal to 2, then what we expect, we expect that whether fx minus 4 is less than epsilon. Right now we don't know, we check x square minus 4. So this is x minus 2, x plus 2. So, but when I say the distance of x from 2 is less than delta and delta is minimum of epsilon value 5 and 1, so ultimately x minus 2 is less than delta is less than or equal to 1 as well as epsilon by 5, right? So distance of x from 2 is less than 1 as well as epsilon by 5. Is it true?
Yes, sir.
Yes, sir.
And so can I say that x minus 2 into 5, this quantity is less than x minus 2 into 5?
Yes, sir.
And therefore x plus 2 is less than 5 from our previous calculations. So x plus 2 is less than 5 because ultimately x minus 2 is less than delta. But x minus 2 is less than delta, therefore x minus 2 is less than epsilon by 5 also. So this is less than epsilon by 5 into 5, which is epsilon. Right? So verified. Right? Hence, for any epsilon, we can produce delta. Are we able to produce delta? Yes or no?
Yes, sir.
Right.
Yes,
Such
sir.
that whenever distance of x from 2 is less than delta, then distance of fx from 4 is less than epsilon, and hence we conclude that limit x tends to 2 fx is 4. In that case, our function was x square, right? That means limit x tends to 2, x square is 4. Proved. So the procedure is clear, and what is the logic how I construct delta, right? So let f is from R to R. Now I define a function. Okay, so let us look at some different functions. So fx is equal to x cube. F of x is equal to x cube. Okay, before this exercise, let me note one thing. We did this for 2, right? But what is my domain of the function? In previous example, what was domain? R, right? Therefore, next part, prove that for any real number C, prove that limit x tends to C fx is equal to C square, or limit x tends to C, limit x tends to C, x square is C square. So can you prove this for general any value of C?
Yes, sir.
Right, so just 2 is replaced by C, and write down the proof in detail. So let f is a function from R to R, f of x is equal to x cube. Right, now prove that limit x tends to C, f of x is equal to C cube for every C belongs to R. So similarly you should be able to prove this. Not really difficult, right? Now let us go to some difficult problem. Let f from 0 infinity to R, f of x is equal to 1 by x. F of x is equal to 1 by x. So this function is not defined at 0 by some reason, or we cannot define, so that we'll see later on. But anyway, so if c is equal to 2, prove that limit x tends to 2, f of x is equal to 1 by 2. Second, if c belongs to, if c is positive, prove that limit x tends to c, f of x is 1 by c. For any c, prove that limit at c is 1 by c. So we'll discuss second case. First case similarly you can argue, right? Okay, what is our claim? Okay, so let us see positive. Choose any number c which is positive, right? And what is our claim? Limit x tends to c, 1 by x is 1 by c. This is our claim. Fine. That is, we claim that. So what is our ultimate claim? Yes. What is our ultimate claim?
that for given epsilon greater than 0, there exists delta greater than 0 such that x minus c is less than delta, then fx minus L is less than epsilon.
Very good. So we claim that given any epsilon, we can produce delta such that whenever distance of x from c is less than delta, then distance of fx minus 1 by c is less than epsilon. So for any epsilon we are able to produce delta, then we are done. Okay, so how to start the process? Given epsilon, right? So our course process starts with epsilon. Given means somebody gives epsilon, we can produce delta. If it is possible, then we are done, right? Okay, so given epsilon, see, this is in my mind what I want, delta. I am writing in bracket means this is in my mind key. Now epsilon is given and I am trying to find the delta. So this is a process. Well, so how to do this? So consider fx minus 1 by c. So this is our ultimate aim to make less than epsilon. So try to simplify this as we did in previous exercise. So right. First I will try to simplify this expression so that I can guess delta. And what should be my next step from this 1 upon x minus 1 by c? So I will simplify this further. So c minus x upon xc, correct?
Yes, sir.
So this is x minus c into 1 upon absolute value of x into c. Anyhow c is positive, right?
Yes.
So that, okay. Now you tell me what should be the my thinking process, next process, what I should think.
That x is positive or not.
See, my c is here some positive number and I want to make this fx minus 1 by c less than epsilon. That means x minus c into 1 upon xc make less than epsilon. So to control this, to make this amount less than epsilon, I should control the second factor. Do you understand?
Yes, sir.
So somehow I should control this factor. And if I make this less than epsilon, do you think our job will be very easy then?
Yes, sir.
Yes,
So 1 upon xc, if this amount is less than x by x minus c into m, then I can make this less than epsilon so that x minus c is less than m upon epsilon. So from that I can guess my delta. And therefore my task is now how to control this second factor. Right. See, this is just observation. I am observing key. Okay, I want to make this expression less than epsilon. So somehow I have to control the second factor. Okay, so now to control, we need to find some m such that 1 upon this c less than or equal to m. So this we want actually. So how to control? But to control this, it depends on x, right? Controlling 1 upon xc depending on x. So we should put some control on x. But where is x? So we don't know where is x. So we should put some control on what? X. And what control on x we should put? Yes. See, here we need very simple thinking, very straightforward and natural thinking. Do you understand what is a graph of 1 by x? Do you know graph of 1 by x?
Yes, sir.
Yes, sir.
Right. And I am here, I am talking about C. And if I put a if I put a control on x, and suppose I say x minus c less than 1, then what happens? What happens? C minus 1 less than x less than c plus 1. Suppose my c is 1 by 2. C is 1 by 2. What will happen? Then minus half less than x less than 3 by 2. Is it correct?
Yes, sir.
But when I put this restriction ki x minus c is less than 1 and c is half, because I am doing this for general any c, right? And if c is half and I put control on x, then this range contains 0, but near 0 function is unbounded. Function is going larger and larger value. So we cannot control fx in such situation. Do you understand?
Yes, sir.
So in this interval minus half to 3 by 2, if you go closer to 0, function becomes uncontrollable. We cannot control. So we have to be very careful while controlling x. And so what control I should put? I should put restriction on c, so that I will restrict that my x lies in between this range. Right? What restriction I will put on x? I will put this restriction. Like unlike to in previous case I put control that x minus c, x minus 2 less than 1, that was particular c is equal to 2. In that case it was easy, but here if you put this restriction, then 0 is in this range, then function becomes unbounded, becomes larger and larger, so it will go out of control. So certainly we can put this kind of control on c. So mathematically how to write this? Do you see in the figure? Do you understand what I want to say?
Distance of x from C should be less than C.
If less than C, then that will create a problem. What problem it will create? Suppose, okay, let me tell you this also, because okay, okay, let me write on this right side. Suppose distance of x from C is less than C, less than C. That means 0 less than x less than 2C. Am I right? Yes.
Yes, sir.
Yes, sir.
If see, I want what we want m. We want m such that we want a larger quantity, so that 1 upon c less than m. Basically, that means what we want x into c greater than 1 by m. That means we want smaller quantity to xc, so that if we take inverse, that will be the larger quantity. So if you want to control or bound 1 upon xc from upper side, that means we should have a lower bound for absolute value of x into c, because these two things are equivalent. So to have some m greater than this, we should have some number less than this. Do you understand this? Yes.
Yes, sir.
Now what is the problem with this choice? Ki x minus c less than c, what is the problem? Do you realize some problem? Do you realize some problem? See, if see to have up some bigger number, we should have smaller number than xc. But if you want to find smaller number, so x is greater than 0, then absolute value of x into c is greater than 0. But how will you take inverse now? 1 by 0. This is not useful. Do you understand this?
Yes, sir.
So this is a problem. Do you realize the problem? And what makes the problem? So what now observe what makes the problem? What creates the problem? Yes.
0. The lower bound should not be
Right.
0.
So 0. So how you should avoid 0 and keep away from 0. Do not go near to 0. 0 is dangerous for us at this situation. So somehow we have to we want to be isolated with 0. So how to avoid 0? That's why in this figure I am saying this control x in this way.
So we can take c by 2.
Yes, very good. So if x minus c less than c by 2. Here c is positive, c by 2 is positive quantity. That means what? Minus c by 2 less than x minus c less than c by 2. That means c by 2 less than x less than 3c by 2. And clearly this is strictly greater than 0. Now with this range, if x is greater than c by 2, therefore absolute and x is positive under this restriction. When now I am looking at a very specific type of x, right? Which x I am looking at now? X lies in between c by 2 to 3c by 2. I am looking at c by 2 to 3c by 2, and therefore all such x are positive, which is xc actually. And since my x is greater than c by 2, so c by 2, x is greater than c by 2, so therefore into c, right, is greater than xc, which is absolute value of x into c. Is this correct?
Yes, sir.
So c square by 2 is less than absolute value of x into c, and ultimately what I have 1 upon xc is less than 2 upon c square. Right, this is what m we wanted to investigate. So is this correct?
Yes, sir.
Yes, sir.
So the constant we obtain. Therefore, under this assumption or under this control on x, we can see that is which is x minus c upon absolute value of x into c, right? And under this control it is less than x minus c into m. And now what is the process going on in my mind? I want to make this less than epsilon, this quantity. That means x minus c less than epsilon upon m. This is what going in my mind. So what is the choice for delta? So what is the choice for delta?
C square epsilon by 2.
Right. No. What is choice of delta? See this. Can you see this green color? X minus c less than epsilon upon m. If we want to make x minus c into m less than epsilon, x minus c should be less than epsilon upon m. So, what is the choice for delta?
Minimum of 1 by 2c and epsilon c square by 2.
Right. So, epsilon. So, what is my m in this case? What is my m in this case?
2 by c square.
x minus c into 2 by c square, and epsilon upon m. What is epsilon upon m? So c square by 2. So epsilon c square by 2, and what is the additional condition? C by 2. Whichever is minimum, that is the delta. Right? C by 2 is a positive quantity. Epsilon c square by 2 is a positive quantity. And whichever is minimum, we right choose that as a delta. Now verify that.
Sir, I have a doubt.
Yes,
Sir, why did we choose C by 2?
you can choose C by 4, no problem. My problem was, do you understand what was problem? 0 was the problem. So anyhow I
Yeah,
wanted,
0 was the problem.
so 0 was, anyhow I wanted to avoid 0. You can take C by 2, C by 3, C by
Okay.
4. That is also fine.
Any
Because
smaller number except 0, because we want to stay away from 0 because it's not defined at 0.
what is the reason? If something is true in this neighborhood, C minus delta to C plus delta, can I say that something is true in this smaller neighborhood?
Yes.
Right, right. Ki, suppose I say that temperature of this room is, or temperature of your room is 20 degrees Celsius, and you make some small corner, temperature of some small part of room is also less, is 20 degrees Celsius, right? So something
Yes.
is true for some neighborhood, it is certainly true for smaller, and therefore if you take C by 2 or C by 3, if something is true for C by 2, certainly it is true for C by 3, because C by 3 is a smaller neighborhood. C by 3 will
Yes.
give a smaller neighborhood.
Okay.
So that is the main reason. So therefore delta is not unique. Remember this. Like in sequences, the K which we produced
Yeah.
was not unique.
Unique. Yeah. Okay.
So verify that this is the required delta. So how will you verify this is required? Verification means if distance of x from c is less than this delta. So when I say delta, so and delta is minimum, so delta is less than epsilon c square by 2 as well as c by 2, and ultimately x minus c is less than epsilon c square by 2 as well as c by 2. So, if distance of x from c is less than delta, then what is distance of fx from 1 by c? But this we have already calculated, so x minus c into 1 upon xc. And under this restriction, key distance of x from c is less than c by 2, we know that this quantity is less than m. And what was our m? Was our m 2 upon c square, right? X minus c into 2 upon c square. But x minus c is less than delta, so x minus c is less than epsilon upon m, which is epsilon c square by 2. So epsilon c square by 2 into 2 upon c square. So this 2 and c square get cancelled, what remains? Epsilon. Hence, for any epsilon, we can produce delta such that for any epsilon we can produce delta such that whenever distance of x from c is less than delta, then distance of fx from 1 by c is less than epsilon. And what is the conclusion? Hence, limit x tends to c, fx is 1 by c. Now exercise is, if c is negative, prove that limit x tends to c, 1 by x is 1 by c. Even c is negative, that also it is true. So you should prove it. Now from this, and we proved it for general, whatever c doesn't matter. So from that, can I say that limit x tends to 2, 1 upon x is 1 by 2 from above discussion? Right?
Yes, sir.
So,
Because we have proved for any c. So if c is equal to 2, it is true. Limit x tends to 100, 1 by x is 1 by 100. right? So this is obvious now because in general we have proved it. So idea is clear.
Yes, sir.
Fine. Let us do some one more example. So let f from R to R, f of x is equal to x plus 3, right? Prove that. So prove that limit. Okay, so prove that limit x tends to 1, f of x is equal to what we expect,
5.
5. Okay, so how will you prove this? How will you prove this? So how to start the process? How will you initiate the process?
Epsilon greater than 0.
So given epsilon, want delta such that whenever, right, whenever distance of x from 1 is less than delta, then distance of fx and phi is less than epsilon. So this is our aim. So whatever I have written in bracket, this is what we want. So epsilon is given, we want delta such that, not any delta, the delta satisfying this. Okay, so first of all, try to simplify the expression so that we can guess delta, right? 2x plus 3 minus 5. So simplify this expression. So what is it? 2x minus 2. What is it? 2 into x minus 1. Correct? Now can you tell me delta immediately? Because what we want ki fx minus 5 less than epsilon, but fx minus 5 is same as 2 into x minus 2. That is what we want. 2 into x minus 1 is less than epsilon. That is what we want. X minus 1 is less than epsilon by 2. So can you tell me delta immediately? This is a simple observation.
Epsilon by 2.
Right, so choose delta is equal to epsilon by 2. So here immediately we observe, right? Now verify that this is the required delta. Exercise, now verify this. So let f from R to R, f of x is equal to x square plus x. Right. Prove that. See here I was looking at x limit at 1, but you can similarly treat any number. X is equal limit at 2 or limit at any number. So prove that limit x tends to minus 1 of fx is 0. Can we expect limit to be 0?
Yes, sir.
Right. So how to expect and how to prove this? Once you understand the logic and how to decide the strategy, then it becomes very easy. So how to start the process?
Given epsilon greater than
Right.
0.
And want delta. Right, so when we solve any problems from mathematics, so you should always write down what is given and what we expect. Right. If you mention clearly or if you understood clearly what we expect, then your job becomes easy. Okay, so Now let us simplify the expression fx minus 0 so that it is just fx, right? Now what is it? X into x plus 1. By the way, so what we expect here, make me write something here. We want delta such that what?
Mod of x plus 1 is less than delta.
Right. We are plus 1 because we are looking at limit at minus 1. X minus minus 1, x plus 1 is less than delta. Then distance of fx minus 0 is less than epsilon. This is what we expect. So x plus 1 appearing here, which is absolute value of x into x plus 1, because minus 1, so we want to find delta so that x plus 1 is less than delta. Okay, so what is my next task? Because I have simplified the expression fx minus L or fx minus 0.
We need to control x.
So anyhow we want to control x. So okay, so draw the pictures. And in calculus, without drawing picture, it is very difficult to understand. So whatever you are learning, anytime you are studying on your own, try to draw the pictures. That helps a lot. So we want to control. So how to control? Because x is approaching towards 1. And what control I should put? So make control, and remember that we should avoid 0 because 0 creates a problem, right? Yes. What control we should put?
So we can take delta is equal to 1, then
Yeah, actually, if we put control, suppose if x plus 1 is less than, x plus 1 means actually x minus of minus 1, right? X plus 1 is less than what? Distance of x from minus 1 is less than what? What control I should put? What should be this distance? What should be this distance? Half, is it fine? If I take half?
yes, sir.
Right. Then minus half less than x plus 1 is less than half. So ultimately what will happen? Ki minus 1 minus half less than x less than half minus 1. That means minus 3 by 2 less than x less than minus half. Right, that means x lies in between minus 3 by 2 to minus half.
So we can take delta is equal to 1 also, no?
If you take delta is equal to 1, then absolute value of x. If you put delta is equal to 1, then what happen? Minus 2 less than x less than 0. Which delta? Delta is equal to 1. See, delta must be depending on epsilon, because delta may not be independent of epsilon. So if your epsilon is very small, delta is equal to 1 may not work.
Okay, sir.
Right. Somehow it is depending on epsilon. On the top of that, we are controlling x so that we'll get control on this expression. So that what is a control on absolute value of x?
Mod of x is less than 3 by 2.
Right. So absolute value of x. If my x is here, then absolute value of x is less than or equal to 3 by 2. Is it correct?
Yes, sir.
Yes, sir.
Thus, if I put a control on x so that its distance from -1 is less than half, then absolute value of x is less than or equal to 3 by 2, and hence under this control fx minus 0, which is absolute value of x into x plus 1, which is less than 3 by 2 times x plus 1. Right, but and without any formula, any complicated thing, intuitively do you understand, to make this fx minus 0 less than epsilon, I should make x plus 1 is less than epsilon into 2 by 3. Do you understand this?
Yes, sir.
And therefore what is the choice for delta?
Minimum of half and 2 epsilon by 3.
Right, so delta is equal to minimum of half and 2 epsilon by 3. So epsilon is already given. 2 epsilon by 3 number we can calculate, right? And half is the number, fixed number, so choose minimum. Now verify. This is the correct delta. Or you can say a correct delta, right? Because you may have some different delta. For example, if epsilon is equal to 1 by 3, what is delta? Can you tell me delta now? What is delta? Minimum of half and 2 epsilon by 3. 2 into uh,
2 by 9.
2 by 9. Which is a minimum quantity?
2 by 9.
2 by 9. In this case, we should select delta is equal to 2 by 9. Right? If epsilon is equal to epsilon is equal to suppose 1, then what is delta? Minimum of half and what? 2 by 3, which is minimum.
Half.
Half. In this case, we should have delta is equal to half. Right? See, both, why we are choosing minimum. So if epsilon is equal to 1 upon 100, what is delta? So you find it. Right? Epsilon is equal to 1 upon 2021. What is delta? So you just find it. And for any delta, we can, for any epsilon, we can produce delta. Is this statement true?
Yes, sir.
Yes.
Yes, sir.
Now we are in a position to believe that, right? Can you believe now? Therefore, limit x tends to -1, x square plus x is 0. So we believe this, because for any distance from 0, right? For any distance from 0, we can produce delta distance from -1, so that f of x is in this range. That means f of x is ultimately tending towards 0. Fine. So I will give you some exercises. So let f from R to R, f of x is equal to 1 upon x plus 1. So prove that limit x tends to 0, f of x is 1. Let f from R to R, f of x is equal to x cube plus 2x plus 1. Prove that limit x tends to 0 of f of x is 1. let R to R f of x is equal to 3x square plus 5x. Prove that limit x tends to 2 fx is 22. Yes, will you be able to do these exercises?
Yes, sir.
Do these exercises so that we can go ahead, because unless you do on your own you cannot understand the process. Right? Okay. Well, now there are some questions and that you should ask or might be in your mind. And what is the first natural question? What we prove? We prove that limit x tends to c f of x is equal to L. Then what we do? So given epsilon, there exists delta such that something is happening. Now question what you should ask, if you already know limit L, why to prove it? Why to find delta and epsilon? Is this question genuine?
Yes, sir.
Yes.
And did you get, do you have this question or not? Or you didn't think about it?
I didn't think about it.
Right, because if you know key number L is known, how to prove it? Why to prove it? In fact, we don't know number, but we can guess. And what is the answer? The L is the guess for limit x tends to c fx. This is actually a guess. We are not sure, right? We are not sure. It is a great guess. Limit is L. It is a guess. If you prove it, then we are sure, confirm. This is the correct limit at c. Okay. What is the next question you should ask? Yes. What should be the next question? You got answer of first question?
Yes, sir.
So what should be the immediately next question? Yes, you should have some curiosity. Without curiosity, you cannot learn mathematics. Yes. How to guess? Yes. How to guess appropriate number? This could be a limit. How to guess? Does this question make sense? Yes.
Yes, sir.
How to guess the limit? And what is my answer? See the exercises that I have shared. And what's up, group? See the PDF. Did you see the PDF?
Yes, sir.
And see the second part of PDF, how to guess the limit of function. And idea is, suppose, so this is my function, this is my graph of function, and I am thinking about limit at c. So what is in my mind? What is in my mind? So my aim is what, or my question is, this is a function f, graph of function, this is point c, and I want to guess limit of f at c. So I want to guess limit at, so think naturally, don't think that I need some more hi-fi mathematics. Think naturally. What is my question, what is my basic question? What, how to guess limit? That means what I expect basically, suppose x approaching c, where f of x approaches, correct? This is my basic question. Suppose x is here, then I will see where is f of x. Suppose x is some another place which is near c at this position. Suppose initially my x is x1, then f of x1 is here, and next then I will look at some another x2 which is near x, then I will look at f of x2. Right, that means on the domain I will try, I walk on the domain towards C. Just I am standing at this point x1 and I will keep on walking or jumping, and ultimately I am jumping towards C, and at the same time where f of x1 going, where f of, so I am taking jumps. In first step I am at x1, in second step I am at x2, in third step I am at x3, then I will see where my shadow is tending. Suppose your function is a shadow. So, or where a value of function tending. Suppose you are tending towards, for example, you are having some bag and something in your bag. Suppose you are tending towards home, where the material tending towards inside the bag. Right? Do you understand? So, if I walk towards C, then what I expect, if you walk towards C, what I expect, where f of x tends, right?
For C.
Now, so if you are tending towards C by taking some jumps, x1, x2, x3, that means I am taking jumps, ultimately what I am looking at,
X.
sequence, right? And that x at first jump I am at here x1, in second jump I am at x2, in third jump I am at x3, and if this sequence tends to C, ultimately where I am tending, where I am tending,
C.
C. Then look at f of xn, the corresponding values on the codomain, f of x1, f of x2. These values will tend to some number, these values will tend to some number, and that number is suppose L, right? Can we hope कि limit x tends to C, f of x is L? Can we hope this?
Yes, sir.
Right, and this is a guess. We can hope ki limit could be L, because simple sequence will help us to guess the limit. And now look at the exercises or PDF that I have shared. Do the second part, read it carefully. Then next time we'll see. So is it clear?
Yes, sir.
Once we make a guess by some sequence, then prove. Give an epsilon, find the delta. That's it. Okay, well, do this exercise, right? Because this topic is not very easy to understand.